In this video, we'll build a steel target with a self-healing polyurethane overlay, creating a high-impact system that combines durability, ricochet reduction, custom color options, and low cost, all while maintaining clear, audible steel feedback. We start with a round steel target. Steel pins will hold the steel insert in place, suspended inside the mold during casting. Because of that, the pins must fit tightly against the model and be incorporated into the mold-making process. To create a 4mm offset over the steel core, we'll use sheet wax with an adhesive backing. The shape of the target is cut out of the wax and adhered to the surface. The entire steel target is carefully wrapped in a layer of sheet wax. All wax seams are fused together using a soldering iron and additional wax. The next step is crucial to properly balance the steel insert during casting. By cutting out the sheet wax around the pins, we allow the molding rubber to cure directly against the steel insert at those locations. Washers are used as guides to ensure a precise and consistent cut. This process is repeated on both sides of the target, ensuring a 4mm spacing between the steel insert and the mold walls once the sheet wax is removed. The entire model is then fine sanded to create a smooth surface and remove any tooling marks.
To create a two-part mold, we'll embed the model halfway into Sculptek's soft oil-based clay. First, clay slabs are laid out and smoothed to form a base. Then, a larger sheet of clay is rolled out to precisely control the thickness. The target shape is traced into the clay and cut out so the model can sit inside. The model is fitted into the clay. Air vents are cut from a wooden dowel and embedded halfway into the clay, just like the model. A larger wooden pour spout is positioned in the center area. Using fine sculpting tools, clay is pressed tightly against the pour spout and along the model edges to eliminate any gaps.
A directional key is cut into one corner to ensure proper reassembly. Additional registration keys are pressed into the clay using a caulking tool. These keys help create a tight mold fit, reducing flashing and minimizing post-finishing work after casting. Mold walls are built from foam board and secured with hot melt glue. Any gaps between the walls and clay are filled with rolled, oil-based clay to prevent leaks and ensure a clean mold. The wooden pour spout and air vents are sealed with Sunite wax and allowed to dry for 30 minutes. For this project, we'll use Smooth Sil 950 silicone rubber. Smooth Sil 950 mixes at a 100A to 10B ratio by weight. When using the full kit, as we are here, it can be mixed as dispensed. For partial kits, an accurate gram scale is required. Parts A and B are combined in a clean mixing container and mixed thoroughly, scraping the sides and bottom. To ensure a complete mix, the silicone is transferred into a second clean container and mixed again. The material is vacuum degassed to remove entrapped air. Always account for expansion during degassing. The silicone is poured into the lowest point of the mold box, allowing it to flow naturally and push air away from the model. The first half is allowed to cure for 18 hours at room temperature. Once cured, the mold walls are removed, and the mold is flipped carefully to prevent the model from shifting. All clay is removed, along with any silicone that may have seeped underneath.
The mold walls are reassembled, and any gaps between the model and the pour spout or vents are filled with clay. The model surface is then cleaned and lightly sanded if needed. The wooden pour spout and air vents are sealed with Sonite wax. A release agent, Ease Release 200, is then applied using a spray, brush, spray method to ensure thorough coverage. Allow 5 minutes for it to dry.
The second half of Smooth Sil 950 is measured, mixed thoroughly, double mixed, vacuum degassed, and poured into the lowest point of the mold box. The mold is checked for leaks and allowed to cure for 18 hours. After curing, the mold box is disassembled and the mold is opened for the first time. The steel pins and model are removed. The mold is cleaned and the sheet wax is peeled away from the steel model. The steel target is cleaned with isopropyl alcohol to remove adhesive residue and ensure proper bonding of the polyurethane overlay.
The steel pins are coated with universal mold release to prevent the urethane rubber from bonding to them during casting.
The steel insert is placed back into the mold and the pins are reinstalled. The mold is closed and secured between two melamine boards. Rubber bands are used to hold everything together. For the overlay casting, we use PMC 780 Dry, an industrial polyurethane rubber with an 80A durometer. It is translucent, light amber, and easy to pigment. Ignite orange pigment is added to Part A and pre-mixed. A small amount of UVO white creates a more opaque appearance. Parts A and B are combined, mixed thoroughly, and double mixed in a second container. The material is slowly cast into the pore spout, allowing it to rise naturally through the mold. As it fills the cavity, air is pushed out through the vents. Casting continues until the material rises from the air vents, indicating a complete fill. The mold is placed in a pressure chamber to minimize trapped air and allowed to cure for 48 hours. After curing, the mold is opened, the pins are removed, and the casting is demolded. The pore spout and air vents are trimmed away, and the seam line is sanded smooth. The finished target is now ready for testing. We tested the target using 9mm handgun rounds from approximately 10 yards. The polyurethane overlay allows bullet penetration while containing most ricochet and shrapnel within the rubber. The impact area may appear slightly raised with fragments captured inside the material. To inspect performance, the rubber coating was removed from the steel insert. The interior shows how the polyurethane absorbed and trapped the fragments. The steel insert can be cleaned and reinserted into the mold for a new overlay, or, as we're doing here, the same mold can be used to cast solid rubber targets, resulting in durable, self-healing targets.
Using this mold system, a wide range of targets can be produced repeatedly across different colors, shapes, and sizes, resulting in a high-impact system that delivers durability, reduced ricochet, low cost, and clear, audible steel feedback.